So let me share screen here and close this up. So we've been talking about physics. We had the rigid bodies, non-deforming objects that respond to forces and collisions. We have the various different properties here, mass, drag, gravity. Is kinematic. One of the examples I had I had several is kinematic objects that sat around. We looked at the constant force component that you can add to an object and apply forces, either linear force or angular force, torque. And you can do it relative to world coordinates or the object's coordinates, relative force. We were talking about colliders. There were they're the primitive colliders that come in the shapes of spheres, boxes, and capsules. These are the fastest because they're defined by geometry. The mesh collider, which matches the mesh of our object. We had a little LERPS that has a mesh composed of a bunch of triangles, and we can use a mesh collider, but not if it has a rigid body. And if it has a rigid body, we'll actually get an error message, and we have to do the convex business. So with our little mesh collider here, my little LERPS, with the collider unchecked, if I do convex, this puts this shrink-wrapped collider around it. And we saw that, that this is inconvenient when we have an archway that we want to be able to walk through. And so instead of using that convex collider, we build a bunch of primitive colliders that kind of mimic the shape. So we make arms and torsos and so forth. I think I ended here with this warning about colliders. And there are three different ways that we can use colliders. One is the static collider, another is the rigid body collider, and the third is the kinematic rigid body collider. The static collider is a game object that has a collider but no rigid body. It's part of the level geometry. It's cubes that walls are built from. It's the terrain, it's trees, things that have colliders that are static. They don't have a rigid body and they don't move. And it's important that we don't move them because the physics engine makes certain optimizations based on the assumption that it never moves. And so a static collider should not be disabled or enabled, moved or scaled during gameplay, as this throws the physics engine into kind of chaos. And these changes can actually leave the collider in an erroneous state. An example is if we throw a raycast against an altered static collider, it can miss it. Even though it's there, it can miss it because the physics engine hasn't caught up yet, or it can detect it at some weird place. If you move a static collider, it won't wake up sleeping rigid body colliders. So static colliders should never be enabled, disabled, moved, or scaled during gameplay. If you want a collider object that is not moved, is not bumped around by other rigid bodies, then you should attach an is kinematic rigid body component to it rather than no rigid body at all. So the kind of ordinary rigid body that we use, non-is kinematic, and that is kinematic is, oh, I don't have an example of it. Oh, the Newtons has an example of it. In Newtons. I have these cubes that are the endpoints of my little chain. And these are not moved. They don't respond to collisions. They don't move because their rigid body is set to be is kinematic. It's this little check mark right here. A body that has that check mark unchecked is fully simulated by the physics engine, and it reacts to collisions and it bounces around. And these other cubes, cube 2 here, doesn't have the is kinematic checked, and it does respond to things bumping into it. And if it's asleep, it will wake up as well. You can move an is kinematic rigid body, usually from a script or an animation. You can modify its transform component. But when you move it, it doesn't respond to collisions. It just goes on its merry way as directed either by the script or the animation, and it'll push other stuff around, but it doesn't respond to collisions and forces like a non-kinematic rigid body. And so these are for colliders that can be moved or disabled or enabled, but should otherwise act like a static collider. An example of this might be some kind of door that is normally immovable, but we want to be able to open the door with a script when necessary. The kinematic colliders will apply friction to other rigid body objects, and it will wake up other rigid bodies. And there are some other subtle differences. For instance, is kinematic rigid body that has its collider set to trigger will needs to have a rigid body in order to receive the trigger events that might be handled in your script. And you can switch between normal and kinematic behavior at any time from scripting by just changing that is kinematic property in the script. An example of this might be a ragdoll effect. I'll show you ragdolls in a little while. But you have a character that normally moves under animation. Its arms and legs walk around and do things. But you have some explosion that goes off that you want to throw the character in a physically realistic way. And so the character's limbs are given their own rigid body components set to is kinematic. So the limbs will then move according to the animation. And when the explosion goes off, we can switch all those to from is kinematic to non-is kinematic. And then the object will respond to the explosive force and the character is sent flying in a realistic looking way. So be careful with colliders. Don't move an object that has a collider but no rigid body. If you want it to be stationary and not responding to forces and collisions, check the is kinematic. And if you want it to completely be controlled by the Unity physics engine, leave the is kinematic unchecked and it will roll and fall and bounce off things and so forth. So any question there about colliders? No, okay. So colliders are good. So there's one other component that I need to talk about, and that's the character controller. And if you look in standard assets, the first person controller, the FPS controller, is a character that uses the character controller. Ethan, the third person character, and the rolling ball, they're both rigid body controlled characters, and they don't. Well, Ethan's controlled by animations and the rolling ball by physics. But if we look at that first person controller, it has a character controller component on it. I think I have one down here somewhere. Character controller. So here's my first person controller, and this is the character controller component. This is its script that runs it around. It does have a rigid body, but it's not actually used by the first person controller script that runs it around. The character controller has a number of properties. It has a height. That's my dog. It has a height. Liba, hush, the mailman's coming. It has a height, a radius, and a center. And you can see that here. It's this little green capsule around the thing. And we usually try and match that to the shape of our character. The FPS doesn't have any visible manifestation, but it does have this this capsule that kind of corresponds to my my character here. And so I can adjust its radius, I can adjust its height and match it to the visible character, which I believe here is a little capsule that I've put on it. There's a little capsule here. You can see it in shaded. It's got a little capsule. So that's the character controller. And it has some other settings. One of them is the slope limit. And this limits how steep a hill our character can climb. It also has something called a step offset, which is how big a vertical step the character can ride up over. And then there's some other things that deal with collisions, the skin width, and the minimum move distance, which is something that happens in code. Later, when we set up our controllers, we'll look at the two key functions that are accessible from scripting, move and simple move, but they're not available in the inspector. So here with this little character, I've got a slope limit of 30 degrees set, and I have a step offset of 0.1 meter. And I've got some steps over here. I believe my steps are meter high. And so my character can't go up them. I'm trying to drive forward here. My character can't go up them. I can cheat and jump and get up them, but I can't just drive up them. And over here, the hill is a little bit too steep. I can't drive up this hill because the slope there is greater than 30 degrees. And I have to go over here and find a spot where it's not quite so steep. And I can work my way up the hill, but I can't go up anything that's greater than 30 degrees. So if I go to a scene here where I've just made a couple little simple changes, I've made the slope limit 45 and the step offset is now 1. And now my little character, when I go up the steps, it very happily goes up the steps. And I believe I can climb these hills without any problem because none of them are greater than 45 degrees. So the character controller lets you set these different properties. You can also offset it so it's not centered on your character. But the character controller is something that we'll use in scripting with the move and simple move that control it. You might look at the character controller script there and see how they do it. But this is another component of physics. It actually isn't completely part of physics. It doesn't respond to collisions. Like if you hit it with a moving rigid body, it does not knock the thing over. And to a certain extent, we can push things around with it, although there are some hiccups with that. So it's kind of a collider and it's kind of a rigid body, but it's not fully controlled by the physics engine. It's more controlled by the scripting that we apply to it. And so we'll look at that later when we get to scripting. That's the character controller. Now there's one more collider that I haven't mentioned, and I'm actually not going to do anything with it here. I'll just show you very quickly the wheel collider. And the wheel collider is this funny thing here. It's shaped like a wheel, but it does some kind of strange things that we'll find very useful when we come to making a car. It has a spring. We can specify the strength of that spring, and we can control it from scripting so that we can turn the wheel and we can drive it forward and backward. And with scripting, we can make this little wheel do stuff that we'll make a car out of. I'll come back to that later, and we'll talk about the wheel collider more in detail, because I want to talk about joints today. So I have to switch here from this one. I used to load them all ahead of time, but that's what crashed my computer the other day. And so we have to sit through the load of these things while we wait here. Okay, so I'm going to talk about joints. So the simplest kind of joint is the fixed joint. And the fixed joint does what it says. It fixes an object into a specific position relative to another rigid body. And one of the key features of all of the joints is that they're breakable. We can specify that these two objects are linked together in a specific orientation, but we can set the force or the torque that, if it's exceeded, will break the joint, and then the two objects will move freely as though they weren't connected. Now, the fixed joint, all of the joints have this break force and break torque, and I believe they're all set to infinity by default. And an object with a fixed joint has a connected object, an object with a rigid body to which the joint is connected. It's attached to that. If the other object moves, the jointed object moves along with it. If the jointed object moves, the object attached to it also moves. And if we don't assign a connected object, it's connected to the world. So it will, if we don't assign an object, the thing will just stay wherever we put it because it's connected to the world. So in this example, I've made two cubes, turned them into slabs. They both have rigid bodies. I've oriented one horizontally here. Where are they? Here's my little object here. I've oriented one of them, whoops, One of them's horizontal, the other one's vertical. And I've put a fixed joint in the vertical one. I've made them into children of an empty game object, but that's not necessary. The vertical one has this fixed joint object. Its connected body is the horizontal slab. Its brake force and brake torque are infinity. And the rest of this stuff we can just leave at the defaults. And when I play this, these objects fall together and bounce around, but they're rigidly connected to each other, and they will maintain that orientation regardless of what happens. If I change that brake force to, I'll guess 5 here, and let this run, and now they'll fall together, but the force was enough to break it, and they then turn into 2 separate slabs. So very handy for building things. You could build a house out of fixed joints, and then when a bullet that applied sufficient force hit the house, you could blow the house up and have it fall all into different pieces. The next kind of joint is a hinge joint, and a hinge joint constrains the object to move about some axis. So it's like a door. A door has a hinge axis, and the door revolves or rotates about that axis. The hinge joint's a little trickier to set up here. Don't save. So here I have this slab, this blue slab here, and it has a hinge joint in it. It has to have a rigid body. It has a hinge joint in it. It's connected to this little sphere up above it. If I didn't have something there, it would be connected to the world. And here's where it gets a little tricky, because I have to look at the little gizmos here that are not terribly well represented in our scene view. Here's the slab. You might be able to see a little orange line over here. That's the axis about which this thing is going to rotate. And we specify that here with the axis. And I'm specifying that the axis points in the Y direction. If I put a 1 over here, notice the axis now points in the 1, 1 direction. And that would mean that this thing would rotate about an axis that looks like this. I don't want it to do that. So let me put that back to 0. Now we can also move where that axis is. I have it at X minus 0.5. Red is the X direction. I have it at minus 0.5. If I move that to 0, it's in the middle of my object. You can barely see it there because of the gizmo, but it's now right there. And if I move this over to 0.5, it moves, whoops. If I move this to 0.5, it's now over here on the other edge of my object. So this plus or minus 0.5 moves it from the edge of the object to the other edge of the object. Let me put it back to minus 0.5 here. So that specifies the direction of the axis, the direction in space that it's going to rotate around, and where that axis is relative to the center of my object. Usually we use the auto configure here, which does this connected anchor. You don't have to deal with that. So let's run this and see what happens here. I've got a little character. The door is there. I walk over and push through the door, and the door swings, and it continues to rotate here. It'll stop when I bump into it. I believe I have a bouncing material here. So this little hinged door is, I can push it around, I can push through it, and it continues to rotate. I believe this will more or less continue to rotate forever because I haven't got any drag on the object. So we can add some other features to our hinge joint. For instance, we can use a spring. And if we put a spring on it, this is going to attract the door to a specific orientation, a specific target position, the angle that the spring wants to get it to at rest. And with that spring, we can also specify how strong the spring is and also how much damping there is that slows the oscillations of our spring. And so here, if I think this scene has now a slab with a spring. I've got the use spring checked. The spring strength is 10. It's got a little bit of damping and it's targeting angle 0. And so now when I run into this, it'll open for me, but it goes right back to the 0 position. And I've got another little, I've got another little feature checked here on this. I've also included something called the limit position. And if the limits is on, it sets a minimum and maximum angle that the hinge joint can go to, and also how much it bounces when it hits that limit. And what I've done here is I've set the limit so that I can go through the door one way. It'll swing to positive angles, but it won't swing to negative angles. So I can't push back through it. And so this you can, of course, use for a little trap for your character, a one-way door that they would go through and they would not be able to get back. So that's set with the limits, use limits. The minimum is -90, the maximum is 0, and it's got a certain amount of bounciness. And so that set the limits. There's also a motor. So let me turn the spring off and turn the limits off. And now the motor is on. The motor has now a target velocity, how fast it wants to spin this thing and what force it uses to, it should be a torque technically, that it uses to accelerate it to that particular angular velocity. And so now my little door is going to spin at 35 degrees per second. I can still push it around and it applies a torque that tries to get it back to that speed. But I, of course, can push it and make it go where I want it to. So that's the motor. And so we can apply a motor to our hinged joint. And that's actually in this 2C scene, I think. This one. Oh, no, this is a different one. So that's one of the things we can do with a hinge joint. Now, here's another clever thing that we can do with a hinge joint. I'll make 3 different objects, a top, a middle, and a bottom, and I'll position them all in a little row. Here they are. They're I've got them hanging off on sides, and the top I'll leave unconnected, so it's connected to the world. The middle, I'll put a hinge joint in and connect it to the top, and I'll set it up so that the hinge is right here. And the bottom, I will connect to the middle with its joint right. Actually, I think this is the top one, middle and bottom. And so now with this object, it behaves kind of like a chain, and it swings around in a very realistic looking fashion. And if you make a longer chain with, say, 10 links in it and shorter links, then you have a very realistic chain that swings around, responds to physics. And I believe we can maybe go over and interact with this thing. It hits us, we hit it. And so that's all very cool. And that's just done with hinge joints. The spring joint is acts like a spring. The fixed joint is fixed. The hinge joint acts like a hinge. The spring joint acts like a spring. And so the spring joint will set up here. Whoops. The spring joint. Accidentally moved it. The spring joint what did I do? Keep moving it when I don't want to. So the spring joint is a ball on a spring, and I believe I've done this. This is an empty game object that just contains my sphere, and the sphere has the spring joint on it. It has no connected body. That's weird. It should have the cube as its connected body, but we'll go on without that. With none, it's connected to the world. So the sphere has a little gizmo too. It's this little orange square here, which is set to position Y of 0.5. I could move it around and place it somewhere else within my object. 0.5 plus puts it at the top, minus 0.5 would put it at the bottom, and we can do the same with the X and Z axes as well, which would put it off on the side. The spring has a strength, in this case 15, and there's a damper that controls bouncing. And then there's the minimum and maximum distances. And the minimum and maximum distances define the distance from that anchor at which the spring applies no forces. It's only when you're outside that range, when you're more than 0.5 distance from that point, that it will begin to be springy. So if I let this thing play here, this thing will fall freely to begin with, but once it's outside that 0 to 0.5 range, it then begins to bounce around and behave like a spring. And I can push that thing and the thing kind of wobbles around. So that's a spring joint. And the gizmos are kind of hard to see, but let me not maximize on play, and I'll let this kind of bounce apart here. And you can see the two gizmos that are separating here. And the force only kicks in when that bottom one is outside the 0 to 0.5 range that we specified. Now I want to take a break here and look at something else here. Moving objects. And this is this involves scripting. And so I'm going to put on my camera the drag rigid body simple script. And I believe I have it. Where are we? Moving objects. So on the camera of my character, I've got the drag rigid body script, and it has various exposed variables, things that we can see in the inspector. It has the spring strength, it has damping, it has how much drag, angular drag, and distance. And these are all things that we're going to use when we move things around. And it's going to use a spring joint. And this one is private, so it doesn't show in the inspector. I believe we can, no, this is not the right one. Never mind. It's a different script in there. So in the update function runs every frame of the game on every object that has an update function. First, I test to see if I have a camera. I'll show you this in a second. And then there are various bailouts here, things that are going to abandon the update function. If the mouse button 0, that's the left mouse button, is not pressed, notice the not operator here, I bail out. I'm going to cast a ray cast out into the world from the camera to the mouse position. And if that ray cast doesn't hit anything, not ray cast, not physics ray cast, I'm going to bail. And if it does hit something, if it's not a rigid body or it is kinematic rigid body, I'm going to return. So all of these bailouts, if I'm not pressing the mouse button, if I don't have anything I'm pointed at with the mouse, and if what I'm pointed at is not a is kinematic rigid body, I bail. If I've successfully found something, the first thing I'm going to do is test to see if I've already made a spring joint. This only happens once, the first time you use this. It makes a spring joint object. So here in this case, we're making a game object in the world by saying game object GO is a new game object with name rigid body dragger. So this makes a game object. It's an empty game object to begin with, but we're making it here in the script. And I'm going to add a rigid body component to it. And I'm going to add a spring joint component to it. And I'm going to set its rigid body to be is kinematic, because I'm going to control this thing with scripting. So it's a rigid body, it's got a spring joint, and it's is kinematic. This only happens once. Once it's made a spring joint, it's there, and we don't have to deal with it again. Here, if I drag one of these objects around, if I stop here and look down here, there should be a ball spring joint. No, is that it? Nope, it's here somewhere. Oh, the rigid body dragger. There it is. I made a rigid body dragger and I set it up. So that was not there to begin with. When I end the scene here, it goes away. But I only need to make it once. Okay, so now I've got this spring joint. Now I'm going to set the position of the spring joint to the point that I hit back here with this right cast that hits something. So I'm putting the spring joint where I'm pointing to in the world. I'm going to set the anchor to 0. I'm going to set the strength of the spring and its damper and the distance that I want the spring to maintain, the distance from me. And I'm going to assign its connected body to be the thing that I hit, the rigid body that I hit. Then I'm going to start a coroutine. We'll talk way more about coroutine when we get to formal scripting here. But the thing I'm passing into this coroutine is the hit distance and the object that I'm using to drag around. And in this enumerator function, and we'll talk much more about it, I catch the drag of the object that I've trying to move. I catch its angular drag because I'm going to set it to be my specific drag that is up here in the exposed variables. And then I'm going to set its drag. And then while the mouse button is down, I'm going to throw this ray out into the scene at the mouse position, and I'm going to move my spring joint around to that position. And then these enumerators have this magic yield where we wait for the next frame. And when I release the mouse button, it's going to drop out of that while loop, and it's going to set the drag of my object back to what it was originally and the angular drag back to what it was originally. And I'm going to disconnect the spring joint from its connected body by setting it to null. And that's how this works. That's how I can grab these objects and drag them around the scene. I can grab them and drag them around. Now, you don't actually have to write this script yourself. There's a version of, or here's the find camera that I did up at the beginning. If the script is on a camera, it'll do a get component camera and return it. But if it's not, it'll find a camera in the scene that is labeled main camera. So that is tagged main camera. So that's just a little trick. Now, if you've loaded rigid body standard assets, you'll find in standard assets down in the utilities a drag rigid body script. This is a script that comes with standard assets, and it's very much what I just showed you. It has a couple of subtle differences that I don't like. One of them is that instead of these spring, damper, drag, angular drag, and distance being exposed variables, they're constants. And so they're not exposed in the inspector, and they're not accessible from the inspector. If you want to change them, you have to edit the script and go in and change them. And one of the problems is that the spring is not very strong. And so I have this heavy object over here in the scene. I have this heavy object over here in the scene. Where is it? The heavy object. Where's the heavy object? This heavy object, which has a mass of 1,000. And if I use that drag rigid body with a spring strength of 50, I can't pick this up. The spring is not strong enough to pick it up. So here's a trick. Here's a trick. If you modify that script and add a public variable uniform force, which if it's true, it will scale the spring constant by the object that we've hit mass. So this is going to automatically make our spring strong enough to pick up anything. And so this is in a scene, I believe, that I call modified. Moving objects, modified. So now the camera has this modified script on it. Drag rigid body modified. It has a Boolean that we can check on or off. And now with uniform force on there, this is going to very happily pick up that 1,000 kilogram object. And it picks up the other ones just as easily, even though their masses are only 1, because it automatically scales the force to adapt to whatever object it is we're picking up and flinging around. So that's all pretty cool. We scale that spring joint, spring, and damper by the mass of the hit object that makes it strong enough. So I'm going to stop sharing at that point and entertain any questions on joints. I believe this week's assignment, you have to make a hinge joint and make a door that you can blow open with your bullets that you're going to be firing from your brick shooter. So we're going to be playing with rigid bodies and joints and piles of objects to knock over, so forth. Any questions?
For the hinge joint, will the door swing faster the farther from the axis it hits?
You mean if, yeah.
Okay.
Yeah, sure. If you push on it close to the axis. Do you mean, does it take more force to push it when you're in close to the axis? I don't know. That's an interesting question. I don't know if it makes a difference. Why don't you try that? Make a big wide door and hit it with a bullet out at the end and hit it with a bullet in close to the axis and see what happens. That's an interesting question. Any other questions? Don't forget to type your name in chat if you haven't already. I'm going to stop recording at this point.